Okay, so today I'm going to show our final project, which is a chess cheating IoT device. For our project, there's two components. First off, we have the hardware component, which is a buzzer with a Raspberry Pi and battery, which will be on the cheater's body. And then the second component is the client component, where we have a computer which can look at the game and tell the device what the best move is and send that over the network. So first off, let's open our client software. As you can see, it tries to connect to the Raspberry Pi. Right now it's failing because we haven't started the server yet on the Raspberry Pi, but once we start it, we can see the connection is a success, and we can see our UI here on our computer. So here we obviously have the board. We can make moves on the board here. We can evaluate the current position here. We can send over the move to the Raspberry Pi here. And we have a couple features down here, which I'll talk about later. So let's just go through what the cheating would look like. So let's say you're playing white, and it's your first move. You don't know what to move. You can press evaluate here. It'll take a sec, but it'll tell you the best moves possible. So sent upon means the higher it is for white, the better the position is. And if it's lower, usually it goes into negatives. That means it's better for black. So we can see here, the computer thinks E2 to E4 is the best move. And if we want to send this to our Raspberry Pi, we can do E2 to E4, and then we can send this move over. So in real life, the buzzer is going off, and I'll show you that later on. But as we can see on our Raspberry Pi here that we SSH'd into, we can see the move E2, E4 did appear. So if we want to actually make the move on the board, unfortunately, the board is not interactive. We can make the move here also, so we can have a visual of this going on. So let's say black made a move right now to put his pawn from E7. So E7 to E5, we can see that we can do this, and then we can just restart everything again. We can do evaluate. We can see, G1 to F3, G1 to knight to F3 here. That would be the best move. And then once again, we can do this. We can send the move. You can see, got it, and now the buzzer is vibrating. And we can also make the move here. Okay, so some features about the board is that we have an undo button. Say like if you accidentally made a wrong move, you can just press undo. This is implemented with a deck in Python. It's sort of like a stack and a queue together. And you can keep pressing undo until you go back to the original position. And then similar to the undo button, we have a reset. So let's say your game is done or something. You can just press the reset button, and this will take you to the starting board position. And let's say you're playing black instead. Obviously, you don't want to see white's position over here. So you can simply just flip the board here. I see all the numbers that corresponds. And this is just rendered correctly. So like if we do E2, E4 again, you can evaluate here. And as we can see, the lower the sent upon, the better is for black. So originally, I think for white, this move was like 40 sent upon, and then now this is 32 sent upon. As you can see, it's in increasing order this way. So simply, we can do E7, E5, send that move, and get the same result here. So yeah, and also there's a couple safeguards too that we put into the software itself. So let's say we're trying to send a move like rook to like H6. So it would be like H8 to H6. This would not work. And we will get a move is not valid. As we can see, it won't send the move since it would probably confuse the cheater. So yeah, so it filters out moves that are not possible. And it's the same thing over here too. So like, let's make the move h8 to h6. It just won't allow us. It just won't do it. But let's say if we want a viable move h7 to h6, that can be made. So yeah, that's just a quick demo of how this chess cheat works. So now let's look at the live version. So, okay, here's the live view of our device. As we can see, here's our Raspberry Pi device here, and then we have our buzzer connected to these header pins that I soldered into the Raspberry Pi. As we can see, originally actually didn't have these headers, so I had to solder these in. This buzzer that I had to solder to a higher gauge, a larger gauge wire, since these leads were very low gauge. They wouldn't fit into the connector here, the connector housing here. So yeah, I had to solder all these together, put in the correct connectors to fit into here. Then simply here we have a very small power bank. As you can see, if I put my hand next to it, like it's like maybe half the size of my hand. This is probably one of the smallest ones they had on Amazon. This is connected to the micro USB onto the Raspberry Pi here. So we had our code still running from the desktop demo. So if we just open up this again, we can make a move for white here. Let's say they want to move from F2 to F4. We can, we want to put that into the send move. Send the move, and as we can see, it's vibrating in Morse code. Yeah, and now it's done. So as we can see, the server also got that. So one thing you obviously need to know is Morse code. So if in order to translate the buzzer into actual moves, we would just need to learn Morse code of F2, F4, and I believe in the code we'll do another rundown, and I'll talk about exactly how this is working. But this is has a dictionary in the back end, and it converts each of these characters, so F and the numbers, so all these 1 to 8 and then A to H, as different dots and dashes, which I'll talk about right now. Now I'll do a quick code run through, and I'll first talk about the server.py. So server.py is what's running on the Raspberry Pi. So we have our setup up here. Pin 17 is what the buzzer is connected to. And then we have our IP address and our socket that we want to open the connection up to. Here is the Morse code that we were just talking about. We can see how 1 is mapped into these dots and dashes, which will be used later. And then we have our functions dot and dash. As we can see, dot is 0.2 seconds of buzzing, and then dash is 0.5 seconds, 0.5 seconds of buzzing. So yeah. The rest of this basically sets up the GPIO pin, and then opens up a socket to listen infinitely. Since we don't really know how long the chess game will be, this will just run indefinitely until you close it on the client side. So here we just decode the ASCII message, and then we run it through the decoder up here, and we just get the dash and dots, and then we obviously vibrate it. So it's very simple here. What's happening. As for the chess cheat pi, it's not really chronological, as we saw, but we can talk about some parts of the code. So if we start off here, the main parts of this that we need is Stockfish, which we call fish, and this will create our evaluation engine, and also Stockfish helps us hold some of the positions. So for example, Stockfish knows exactly what this position looks like. There's something in chess called a fen, F-E-N, which converts this board into a string position, and we can access that from Stockfish, and obviously the evaluation is being done by Stockfish too. And if we take a look at what this does, is that we have our Stockfish executable over here, and we can set the valuation depth here too. And this can be changed depending on how strong your computer is. For my computer, I did a depth of 20, but I know on my laptop a depth of 20 is very intensive. So you can set that a bit lower if you're using like a laptop or a mobile device or something like that. Okay, so socket, tries to connect to the socket we opened, and this will just infinitely loop before we open our GUI as we saw before. And then in our window, this initializes our tkinter window. In here, this is basically what's rendering all these buttons and telling what each button does. I won't go through this, but yeah, that's what it's doing. And over here, we just have some closing things that happen when the GUI is closed. So, like for example, on closing, we have a function here that like closes and pops this up. So, do you want to quit? And we say okay or not. So, yeah, that's what that does. So, we can talk through some of the specific functions. I think are pretty interesting. So one of them is the display board. The display board is probably one of the hardest things, even though it doesn't seem like it is. I talked about this in the documentation in the report a little, but we get our fem position from Stockfish and we put it into this chess library. And from the chess library, we can also get SVG representation of the board. So we can open this up and we can see this. And we open that and write to that file, and then we have to convert it to a PDF. So one thing I talked in my report is that for some reason rendering an SVG in tkinter is not possible. And also when I try to create a JPEG or a PNG of an SVG, it has really bad artifacting, but with PDF, it actually renders correctly, as we saw before. So a lot of this is just like turning the board notation into an SVG and SVG into a PDF, and then ingesting the PDF into an object that we can actually render using Pillow and its image TK photo image here to render the image of the board. Yeah, so this was pretty complex, and in the future we would like to have an interactive board, but just figuring all of this out took quite a while and a lot of troubleshooting. So we decided, that was just enough. So in the future we might implement the interactive board. Another interesting thing is undo move. So what undo move has is a deck in the back end, like we talked about, and then it pops it when we press undo, which is a cool use of data structures. So send move sends the move to the socket. So we use socket.send here, and we open up the socket earlier, initialize that, and this will send it to the Raspberry Pi. So this is where it also does the error checking to check if the move is possible against the Stockfish list of moves, and if it isn't, we can say move is not valid. And yeah, the rest of this I'm not going to really talk about, but that's just a quick run through of how the client works. Okay, so yeah, thank you for viewing our video, and please look at our documentation. We have a lot of documentation in our report talking about the technical approaches, what challenges we had, and some of the hardware details. So yeah, it's been a really fun project, and me and Vikas had a great time doing this project, and we learned a lot, both from the software part, implementing the GUI, and also on the hardware part, since I didn't really have any soldering experience. So trying to assemble the Pi and soldering the header pins and the buzzer was quite an experience. But yeah, overall a very good experience.